Hello. Thank you for joining us for today's Caringo Tech Tuesday webinar. This session's topic is selecting hardware for object storage. I'm Sarah Cook, Director of Marketing at Caringo. Before we get going, let's go over just a few operational details. We've loaded some useful resources that you will find in the attachments and links box on the right side of your screen. I see somebody has already found that and started downloading attachments, so that's terrific. There is also a question field. Please feel free to ask questions throughout the webcast, or you can save them for our Q&A time at the end. You can also email us at info@caringo.com if you'd prefer a written response via email. Our subject matter expert today is John Bell, Senior Consultant. He will be available to answer your questions after his presentation. And John, it is so good to have you back on Tech Tuesday.
Oh, great. Thanks. I'm glad to be back.
So I'm celebrating 5 years with Caringo soon, and I'm very happy to be back in the host seat of Tech Tuesday. I believe this is where we started a couple of years ago, John. Am I right?
Yeah, that sounds about right.
So tell us what you've been doing these past few months, John.
Well, sure. Let me walk through it. Some of the regulars may have noticed that I've had to step away from my usual Tech Tuesday schedule. I've had some other tasks here at Caringo to tackle, and one of those tasks happened to be assisting with the development of our new object storage appliance line. And we plan to cover that in today's presentation. So for those who aren't familiar with my role here, I've been with Caringo for over 8 years as a senior consultant, and I've had the opportunity to deploy swarm storage solutions across the world. And I hope that experience as it relates to hardware selection, I do a good job of sharing that with you today.
Terrific. So you're going to tell us the hard and long way and also the easy way to get set up for an object storage implementation, right?
I like to call it the full custom do-it-yourself way versus the turnkey way. And you can do it both ways. That's the magic of our solution. We'll cover both sides.
Great. I think most of you are familiar with Caringo, but just in case you aren't, we were founded in 2005, and our mission was to change the economics of data storage by enabling relentless data growth. Today, Caringo's software-defined object storage solutions are used across many industries by organizations such as the Department of Defense, the Department of Justice, the National Institutes of Health, Argonne National Lab, British Telecom, NEP, Rutherton Appleton Labs, the Brazilian Federal Court System, and I could just go on and on. We are very excited about being here today, and I will turn it over to John now.
Excellent. Thank you, Sarah. So just a quick rundown, everybody, of the agenda we're going to cover today. We'll start off with an overview of hardware requirements for object storage, a quick discussion around building it yourself from scratch versus buying a turnkey pre-made appliance solution. If you do plan to build it yourself, we'll go over some of the considerations that you need to take into account before you purchase your hardware. Then we'll walk into the Swarm Server appliance line and go through those specifications and details around that and some of the thinking that went into why you see the hardware profiles that you see in the appliance lineup. We'll talk about expansion strategies and reference deployments, and we'll dive into the software components that go into the Swarm servers proper, and then we'll wrap up with a listing of upcoming events and any leftover Q&A that we need to cover. So with that said, let's dive right into it.
Slate.
It is. Well, we're going to cover a lot of ground today. So let's start off with the build or buy conversation. This is typically what people have to make a choice of up front when they're considering deploying an object storage solution. And you have pros and cons for each side. With build your own, of course, it's going to require a little more pencil work on your part for sizing the hardware, getting the purchasing lined up for the specific equipment you want to buy and how you plan on doing integration with it and so on. The advantage to build your own is it can be designed to meet your specific requirements for the workflow or the application or service that you're trying to design. And the other pro, of course, is that the units of purchase and licensing is often very flexible when you go with a build-your-own approach, and you can build it out on demand. On the turnkey side of the house, turnkey solutions, by definition, show up ready to deploy. They have all the scripting and whatnot ready to go so that when you first power up the unit, it doesn't take very long for you to start using the object storage solution that's been dropped off in your office. Now, that said, it may not meet all the specific requirements that you need to cover right out of the box. In our situation, we've tried to design the appliance lineup with a little bit more flexibility in mind. We'll talk a bit about that as we go through the presentation. But it's not a customized solution, so you lose a little bit of flexibility, but what you gain in being able to turn up and start using it quickly is where turnkey shines. The units of purchase and associated licensing may not be as flexible, but I think we've done a good job of covering that with our appliance lineup. And like I say, we'll go through that as the presentation progresses. So from a generic component choice, we'll walk through the main components that we typically size Swarm Object Storage workloads around. And of course, we're going to focus on the big ones. We're going to focus on CPU, disk, memory, and networking. Those are the four key areas that we look at when we're putting together a hardware solution. On the CPU side of the house, Swarm Storage supports standard x86-64 CPUs, be they Intel or AMD. Both will work very well with our solution. We do support single or multiple sockets. Obviously, multi-core we support. Hyper-threading is supported, all of the features that come with these CPUs. One specific recommendation we can make is that when you do purchase CPUs, make sure that they include the AES-NI support, or Advanced Encryption Standard New Instruction support. And the reason we call that out is that our encryption at rest, or EAR implementation, is purely software implemented, and we take advantage of those instruction sets in these modern CPUs. Most CPUs, be they Intel or AMD, are going to have that instruction set in place as of 2010. So anything you buy today brand new is definitely going to have that, and we do recommend it.
And I'm betting there aren't too many servers out there that haven't been refreshed in the past decade.
Yeah, in our experience with deployments we already have in the field, Sarah, most people are refreshing their equipment anywhere on a 3 to 5 year schedule. So you're pretty much guaranteed with new equipment on a refresh, be it purchase or lease, you're going to get the features that you need. Okay. So let's dive into memory. Physical memory, of course, is going to be very important in the case of Swarm, because what we do in Swarm is we index where objects live on the disks in main memory. That's why we say, there's basically a zero disk IOP to finding something in Swarm, because its location is already loaded up in main memory. You don't have to run the arms on the disks to find it. It's already been found and indexed. The amount of memory you need, of course, is going to be a function of the number of objects that you plan to store in our object storage solution, and also the type of objects they are and what kind of protection scheme that you plan to use with object storage. And we have a chart here that demonstrates that for different memory sizes, how many objects and what object types they are can be referenced within Swarm. The main takeaway from this chart that I want everybody to focus on is the fact that this is a linear scale. Our utilization of memory is linear when it comes to this. I like to tell people that it's very easy for me to size memory for a solution, especially if they know up front how many objects they plan to store in Swarm, and even in more detail if they know what type of protection scheme they're going to use. If they have an idea of what those two things are, it's very easy for us to size how much memory you're going to need on each one of the servers in the cluster.
This is the math you were talking about.
That's right. The math is quite simple. It's algebra. We don't have any weird curves or anything like that built into the solution. It's all linear and easier to understand. In the case of larger clusters, you should plan for adding additional memory for features such as the overlay index, or other features that may require additional resources. If you plan on buying your own hardware yourself and you have some idea around what those requirements would be, you can always work with us here at Caringo, and we can give you an idea as to how much additional memory that would be needed, depending on the features you plan to leverage. It's some very minor consulting work. It's very easy for us to do. Our next component to take into account, of course, is disks, or you may hear me jump back and forth between calling them disks or volumes. That's just our terminology that we use for the storage proper. In the case of disks, we definitely recommend that they are direct attached disks. We can support external trays, and we'll talk about that a little bit as we go into the appliance lineup. You typically see that for requirements where very high level of drive density is required, but for the most part, we recommend direct attached storage. Basically, that resides within the chassis of the server itself. The controllers that we're looking...
We had our first question come in.
Oh, okay. Yeah, I can pause for that real quick. Is the object indexing done? Yeah, done on node power on boot. I see it. sorry to step over you, Sarah.
No problem.
The answer to that question is yes. What we do is when we first boot up the system, the Swarm storage will walk through the volume, and it will basically float up into main memory all of the objects that reside on that specific volume. And at that point, it knows where, if a request were to come in from a client, it knows exactly where to find that object within the system because its location is loaded up in the main memory. But it does that on boot. You typically see that in what we call the mounting stage. If you were looking at our Swarm console on boot, the mounting stage is where everything is being indexed in the main memory. Good question. Okay, where was I? I was on controllers, wasn't I, Sarah?
Yes, you are.
Okay, very good. Well, so what type of controllers do we recommend for handling the disks in your servers? We recommend either SAS or SATA, JBOD, HBAs, or host bus adapters. We prefer SAS. SAS seems to work best for a lot of features, especially when it comes to things like hot plug connector or backplane support. And as to the type of disks that we're looking for, we don't really want people to be using consumer disks. You can use consumer disks, but they don't work very well for the type of duty cycles that you see in a 24/7 usage of a storage solution. We're looking for disks that are designed for a 24/7 continuous duty cycle. We want them to fail fast, meaning that if the smart information or equivalent pops up and says that there's some kind of error with the drive, we don't want to keep retrying on it. We want to mark that volume as failing and then reconstruct the data that is associated with it elsewhere in the cluster in a very fast fashion. So enterprise-grade drives have that kind of behavior, and that's what we're looking for. Typically, these drives are going to come with a 5-year warranty. Some examples that you'll find out in the world are Seagate Exos, Western Digital Gold. There are many others to choose from. The key here is that when you're looking at the technical specs and the warranty specs for the drives, you're looking for a 5-year warranty and something that's basically labeled as being quote-unquote enterprise grade.
So John, the next question that came in was, what erasure coding algorithm are you using for reference here, and what performance are we using as a base reference in the previous slide?
Well, let's go back to the previous slide and make sure I'm looking at the same thing along with the audience. Okay. Well, we're not really laying out any megabytes per second here. This is physical memory sizing. So, you know, whatever megabytes or gigabytes per second the memory channel supports on the hardware, that's what we're working with. You know, this isn't a disk I/O chart, if that's what you're getting at. As to what kind of erasure coding algorithm we're using for reference, we list it right here, 5.2 erasure coding. Let me dive into that a little bit. For our terminology, when we say 5.2, we're talking about 5 data and 2 parity. You sometimes see us refer to that as a KP tuple, but it's 5 data and 2 parity in RAID terminology is what we're working with there. And hopefully that answers their question.
And we do have a performance white paper that you can access from our site to get more information about performance.
Right, and in that white paper we list the hardware that was used, so that'll give you a feel for, this was the hardware that was used, this is the performance that was observed, and you can scale it up and down roughly depending on different hardware choices, and honestly, more importantly, network choices, because when it comes to these type of performance metrics, the networking is very important, and we'll talk about that here in a little bit.
Yes, that's on the white paper's resources page on our site. If you have any trouble finding it, feel free to just email us, and we'll be happy to send you that link.
Mm-hmm. All right, very good. I think I've said all I can say about drives, and we talked about networking. So let's go ahead and dive into that. When it comes to swarm networking, we work with standard Ethernet, standard Ethernet switches and so on with the appropriate connector type. We often get a question, Sarah, what kind of connector type should I use? Honestly, from our perspective, we're not really concerned with the physical layer, just as long as it's Ethernet. We're happy.
Okay.
The speeds for Ethernet can range anywhere from 1 to 10 gigabit Ethernet or higher if needed, and we've tested higher. We've tested all the way up to 100 gigabit Ethernet. We know that works. The hardware support that we provide in the kernel layer for our solution definitely has the drivers in place that can support those type of high performance Ethernet cards. It's already there. It comes right out of the box. So if you have plans on using that, you can use it, right out of the box. But typical deployments, we see 1 or 10 gigabit. Usually those ports are bonded with some kind of bonding algorithm that's associated with the Linux kernel. It's the Linux bonding modes that are used. The typical one is balanced ALB. We do support other bonding methods, and specifically we also support 8023AD for LAG, link aggregation group, or link aggregation control protocol if switch redundancy is required for your deployment. And we do have customers in the field that use this. We also support jumbo frames. Most of our customers don't use jumbo frames. There's a couple of specific, very tailored use cases where they've turned on jumbo frame support. Most people are perfectly happy with the standard Ethernet frame size, but we do support jumbo frames if you need that. And the typical frame size that we would recommend would be 9,000. That's basically the least common denominator for what we typically encounter for various Ethernet cards and the switches that they connect to would be a 9,000 frame size for jumbo frames. Typical vendor choices for Ethernet cards. Most of the time we're working with Intel or Broadcom. We also work with Mellanox. We work with various other Ethernet implementations, but the vast majority of them that we see in the field, people are usually purchasing Intel or Broadcom. Those work really well, and the driver support on them specifically is incredibly good from Intel and Broadcom, and that helps not only with stability in the solution, it also helps with performance, because a bad driver can kill performance. All right. So let's dive into the minimum hardware requirements for running Swarm storage. We talk about Swarm being a scale-up, scale-out architecture, but Swarm can also scale in the other direction, and this can come in handy for your developer teams if they just need a very small environment where they need to just interact with the API, perform some functional testing. Swarm is perfectly capable of scaling down to very small deployments that in fact can even run completely virtualized if necessary. And we offer a developer pack on our Caringo Connect website that is a completely virtualized environment that you can run on a laptop. And you would be able to do your development work against that, and then deploy your solution against a full-blown, completely scaled out, dedicated production implementation, and it will work. And that's the magic of it. A small hardware requirement, you're looking at 3 or more nodes or chassis for storage in a cluster. Again, they can be deployed completely as virtual machines. They do not have to be dedicated equipment. As far as sizing these images or the machines, if you do use dedicated equipment, you don't need a lot of memory. 4 gig of RAM will do it. You do need an x86 64 CPU, at least one disk drive, and some kind of network connectivity. The bare minimum would be 100 megabit Ethernet. Most people don't work with 100 megabit Ethernet. They'll have gigabit, and that'll work perfectly fine. That's a nice, small, tight, quote-unquote swarm storage node to work with. That's what it would look like. As far as moving up into something that's a little more robust, the recommended hardware for production storage, you're looking at multi-socket, multi-core x86 64 CPUs in your server chassis. As we mentioned previously, we're looking at deploying on enterprise-grade SAS drives with the associated SAS controllers that are JBOD HBAs that go with that. The amount of memory that you're going to have in the server, again, is going to depend on your anticipated object count and other factors such as the protection scheme that you plan to use and other memory-intensive features that you may plan to use with the swarm storage and so on. At minimum, you're going to want to have 4 nodes or servers in a production stance cluster, and then you would just scale up and out from there. Typically, these are going to be physical servers, but they can be virtual machines as well. Most people, once they're moving into production, they're deploying their storage on physical equipment, and that's what you're going to see. It starts out with a minimum requirement of around 8 gig of RAM or more, multiple disks within a server, perhaps 2 or more gigabit Ethernet or 10 gigabit Ethernet ports in the chassis for redundancy. That's kind of your Lego building block for scaling up and scaling out a production swarm cluster. So what are some of the additional components on top of swarm storage that you may plan to deploy, and what do their hardware requirements look like? In the case of the Swarm Platform Server, the Swarm Platform Server is basically the management server. It's responsible for booting, monitoring, and managing the storage cluster proper. This can be deployed as a virtual machine. It does not have to be physical equipment, although you can deploy it that way if you want to. And we even make a VMware OVA available to deploy it in this fashion. The amount of CPU that you need for it is not onerous. It's about 2 virtual cores, basically, 8 gig of physical memory, 80 gigabytes of drive. More may be preferred for large clusters, and primarily that's due to the fact that large clusters are going to generate a lot of syslog activity for logging, and you want to make sure you have enough disk to capture all the logging activity that's going on in the storage cluster. The networking that it can use would be gigabit Ethernet typically. We would recommend 2 ports for redundancy if you can do that. That's a nice starting point for a production platform server. And you only need to have 1 of these. You can deploy multiples of these. What we found in practice, though, is that most people take advantage of their virtual machine infrastructure, and they allow that virtual machine host infrastructure to take care of failing over the virtual images from one host to another should it go down. So for the most part, people just deploy a single platform server, and they let their host VM infrastructure take care of the redundancy piece. All right. Another component you may plan on deploying would be the Swarm Elasticsearch implementation. And Swarm Elasticsearch is needed if you plan on doing list and query operations on the object's metadata characteristics within Swarm storage. When we size this, we assume a full index of all object metadata, and that includes any custom metadata that you may have associated with the objects that you stored in the system. And primarily, this is going to drive the amount of memory that you're going to need in Elasticsearch. Elasticsearch is very memory intensive. These can be deployed as virtual machines, or they can be deployed as physical servers, either way, depending on what you have available and what you feel more comfortable in working with. As far as CPU needed, again, 64-bit x86 is going to be the CPU of choice. It can be multi-socket and or multi-core. The amount of memory that you're going to need, in this case, it's going to cap out at the most at 64 gig of memory per Elasticsearch server. And there's a reason for that. and this comes straight from Elasticsearch. They do not recommend that the Java max heap for running Elasticsearch exceed 31 gigabytes. So there really is no point in having a huge monolithic Elasticsearch server that has more than 64 gig of memory on it as a result. All of the memory will be used even though they stop at a 31 gig max heap, because the remainder of memory is utilized in the Linux file system cache. So between those two things, you see full memory utilization in an Elasticsearch server. The amount of disk that you need is around 1.5 terabytes for 1 billion distinct objects and the metadata that's associated with them. A little background on that: when we sized it to that number, the amount of custom metadata that we assumed for each distinct object is actually quite large. I believe it was 15K or maybe even larger per object, which, that's a lot of custom metadata in practice, but most people don't come near to approaching that. So 1.5 terabytes of disk for your Elasticsearch farm is certainly reasonable. Another note on that, and this comes from Elasticsearch as well, we certainly recommend that for the disk for Elasticsearch that you use SSDs. SSDs and Elasticsearch are peanut butter and jelly. I'm not going to go into great detail on that because the Elasticsearch team does a great job of describing why SSDs work best for their solution, shards and performance and things of that nature. But we definitely recommend, we pass that on, that you use SSDs for your Elasticsearch farm if you can. As far as networking is concerned, we'd want to see you start off with 1 gigabit Ethernet. One of the things that I like to see is if you do have a large cluster that has a large Elasticsearch farm connected to it, and gateways as well, and we'll talk about gateways in a little bit, make sure that the networking throughput and latency match up with each other. It's just good practice. It seems to work best that way. So if you had 10 gigabit Ethernet that you were using in your Swarm storage cluster, plan on using 10 gigabit Ethernet with your Elasticsearch farm if you can. It's good just to match things up that way. From a server count perspective, we recommend that minimum you start off with around 3 to 4 Elasticsearch servers in your Elasticsearch cluster for this work. You may feel the need over time to scale to as many as 5 or more, depending on the number of objects that you're storing in Swarm and the need to index their metadata information. But 3 to 4 is a good starting point. If you know up front that the cluster is going to be very large and you plan on deploying it in a very large footprint right up front, you may decide to go to as many as 5 servers for Elasticsearch. All right, so we talked about list and query with Elasticsearch, and we talked about storage proper. Last but not least is Swarm Gateway. What does Swarm Gateway do? It is a reverse proxy that sits between the clients and Swarm storage, and it is used as a authentication and authorization gateway. It handles the hooks that are needed for quota and billing. And then last but not least, it is also a protocol translator. So it can handle multiple protocols at once, such as SESP, which is our branded protocol for simple content storage protocol, alongside other regularly encountered protocols such as Amazon S3. They can all be handled at the same time within the same gateway. Typically what you see in front of that is some kind of SSL or load balancing layer. The gateway itself does not do that. It doesn't take on that role, and that's why its hardware requirements are not very large. A lot of that has been offloaded. So for the CPU side, you need x86 64 again, and that can be multi-socket or multi-core. You'll start off with 4 gig of memory, and disk you'll start off with 4 gig minimum. 1 gigabit Ethernet. Again, if you have a 10 gig cluster, I would use 10 gig for the gateways as well. Just keep the throughput consistent all the way through the solution. And in the case of gateway, you don't scale up, scale out. You scale out. Think of a web farm or a web server pool sitting behind a load balancer. If you start off with 2 gateways and you're taking in enough client traffic that you feel like those gateways are being, reaching their limits or overtaxed, you don't make the gateways bigger. You just deploy a 3rd gateway and a 4th gateway and a 5th gateway within the same pool definition behind the load balancer, and that's the way you would scale a gateway implementation in from Swarm. And again, these are very lightweight. They can be deployed as virtual machines or physical servers, depending on your preference or requirements. Okay, so that should give everybody a reasonable understanding of some of the sizing considerations, the thought processes that go into deploying it on custom equipment, do it yourself. And we've taken a lot of that thinking and a lot of that experience, that we have from the field, and we've been able to leverage that to create the Swarm Server Appliance lineup. And what that means is we offer a turnkey solution for on-premise private cloud storage that has been designed, up front to basically meet the vast majority of use cases that we encounter in the field with our current deployments. And again, the advantages this brings to you is that you're going to have rapid and flexible deployment. It comes out of the box turnkey. You just fire it up. It automatically configures itself, and you're good to go, with just a few simple inputs. You can optimize your durability or footprint. You can mix these single, standard, and high density solutions depending on how your workload grows or how your workload changes over time. It's going to be very feature rich for your end users. You're going to have a lot of built-in content management and search capability. And in addition, you'll have secure content sharing and content delivery that's ready to go out of the box as well. And overall, this makes it a very easy experience for your storage operators, for your administrators. We like to say, this bullet right here, one sysadmin can manage 50 plus petabytes of object storage. To be fair, the 50 plus petabytes is just a stick in the ground. We have single administrators out there administering hundreds of petabytes of storage, just on their own. And the way things, yeah, go ahead.
So I know I would want the easy button of buying something pre-configured, but what kind of use cases is this appropriate for versus somebody who would want to build their own?
That's a great question. I was going to cover that a little bit when we went through the various deployment profiles in a future slide. Yeah,
I've got to know where to go.
But again, this goes back to, and maybe some in the audience aren't aware of this if they have not used our solution before. Swarm Storage has the capability to provide our engineering team with telemetry as to how the clusters perform over time. And what we're able to do is we're able to take that telemetry and we're able to formulate, what amounts to an 80-20 rule around use cases for what are typically encountered in the field. And what we've done is we've taken that and we've created the appliance lineup around what's encountered in the field so that we know that if you turn up the solution with a given number of storage nodes or a given number of management nodes or whatever in the appliance lineup, it's going to meet your use case just fine. And we've modeled this against use cases such as video delivery, other media and entertainment needs. We've modeled it after health science data. We've modeled it after other high-performance computing use cases and so on. It ranges across a very large spectrum of verticals that we've deployed against in the field over the past several years. And ultimately, that's what we're trying to tackle in these appliance profiles. Does that answer the question, Sarah? Hopefully that helps.
Absolutely. Well, and it gives people the benefit of our experience.
Right. Absolutely right.
We've been out there deploying systems for a long time now.
Yes. Okay. So let's start off with the Lego building blocks for the Swarm Server Appliance line. They basically come in three flavors. One of them is a combined use case, and that's the first one right here. There's the first hardware profile. I'm not going to go into those specific specs. I believe we have the data sheets available for them to download, don't we, Sarah?
We do. We also have a copy of this presentation that they can download.
Right. So you'll be able to pull
links to all the other information.
Right. So you can pour over the fine-grained details there. I'm not going to spend a lot of time on that. But be aware that these are the building blocks. The first one is used for the role of either being a single server appliance, or SSA, or it can act as a medium-sized S3000 storage server for actually storing the object data itself. It all depends on how you want to use it. And since it's a software-defined solution, the software that we load on it is going to change what it does. In the case of the single server appliance, you're getting the full stack of everything that we offer, and we'll go through that in another slide here in a little bit. In the case of a storage server, it's just storing the objects themselves for that hardware profile. The second one, what we call the HD 5000, is the high density storage server. That's going to have a lot of disks in a physical chassis, and its primary role is for dense object storage. And then finally, we have the M1000 management server, and it has all the platform management server pieces, plus the other satellite components such as Elasticsearch and Gateway and others that we'll talk about here in a little bit that are used to support the turnkey solution. In fact, we even provide a load balancer out of the box for you. We'll talk about that in a slide here in a little bit. But these are the main building blocks that you get to work with when you're formulating, what you want to put together for your storage solution using our appliance lineup. Okay. And associated with that, if you're not really sure how I should mix and match these building blocks, we provide you with some reference deployments. It starts off with the single server appliance, which of course is just a single machine. And that single machine is going to have loaded on it all of the components that are associated with Swarm storage, Swarm search, Gateway. It's going to have HA proxy for the load balancer, and so on. All of the pieces in a single box. This expands into Swarm servers, where you would start off with a M1000 for the management piece, and then you would start off with a minimum of 3 of the SSA/S3000 profile that would be your storage. And then it expands to 1 petabyte using an M1000 and multiple S3000s, 2 petabytes for the same, and then finally for very large deployments, you're going to want to move away from that 1U profile of the S3000 and start moving into the HD 5000 profile for the storage with redundant M1000 sitting on top of that. So that this gives you a rough idea of how we would scale things, depending on, if a customer comes to us and says, we plan on deploying, X amount of petabytes in the first year, and then we plan to scale to Y amount of petabytes or even exabytes 1, 2, 5 years from now. Please tell us, which appliance choice, which reference deployment you would recommend, and we would give you a recommendation accordingly.
And this really gives them the opportunity to start small and then build and add more hardware as their needs grow. And so it's very much the pay-as-you-grow model that we've always had.
Yes, that's right. And another key takeaway from this, Sarah, is that you can run these S3000s and these HD 5000s side by side. There's nothing to prevent you from doing that. The Swarm software does an excellent job of making sure that all the data is properly balanced and bitted across the differing hardware profiles. It's designed to do that, right out of the box. There are no specializations or changes that are needed for the software to do that. And what that allows you to do is basically have some flexibility in changing your hardware profile. Those of you that are of course renting your rack space, you may do the cost math for the footprint for rack and floor space and so on, and or even for a number of network ports that are needed, and decide that I want to move from a large pile of S3000s to a set of HD 5000s that don't have as much need from power port, network port, so on, type of things that you may be billed for at a data center. And the magic of this is that you can drop in those HD 5000s, and while the system is live, the clients never notice this. You can run a retire job on the S3000s. It will move the data transparently over to the HD 5000s, and then when the retire is complete, you can just shut those S3000s down and decommission them, and your service is up the whole time while this is happening. You don't have any downtime while you're doing this, and the clients don't notice.
John, just how much time is involved in adding additional storage? Once you have your initial cluster set up, which I know what takes hours, not days, but maybe a few hours, but
right.
Then you want to grow it, and so you buy another server to plug into that cluster. How long does it take?
It depends on how long basically it takes for the drives to be formatted in the new server, because you'll plug it in, it'll boot up onto the storage network, the platform server will recognize its presence, and it'll boot the Swarm image on that machine. Again, this is bare metal. We don't put an operating system on the storage servers. The only thing that's on the drives on the storage servers is data, and that's the key here, and that's why it's so easy to do. You boot up the runtime in main memory, it goes out and finds all the drives on that new server, it formats them for use by Swarm, and then it announces its presence to the rest of the cluster saying, hey, I'm here, I'm ready to be used, you can start sending client requests my way. Or you can start balancing data that already exists onto my volumes and start moving things around as needed. All of it's automatic. It requires no operator intervention at all.
That's terrific.
Any other questions on this for this one, Sarah?
I think that covers it.
Okay, let's go ahead and proceed then. All right, so let's talk a little bit more about the software that's included in the appliance lineup. When you fire one of these up, what's the thing you're going to see? You're going to see basically what amounts to Linux KVM. You're going to have KVM images. The host OS software is going to be based off of CentOS 7. The various components that we offer will be booted up as guests. That would be the Swarm platform server, potentially Swarm storage. In the case of the SSA, it would be Swarm storage as well, because that would be a virtual machine image. You'll see the gateway implementation, and that's there both for our native protocol and for S3 support. You'll see Elasticsearch for list and query of metadata characteristics for the objects that are stored in it. We also provide a HA proxy as a software load balancer, and then that's also your framework for dropping in the certificates that you plan to use for TLS offload. That's going to happen there. And then last but not least, as an optional component, and it's optional because it's licensed separately, we can deploy Swarm NFS on these appliances for you as well. So those are the big components.
Can you also do Swarm NFS on a single server appliance, or do you need the larger components for that?
Yeah, that typically falls into custom implementation, where you would deploy it as its own dedicated virtual machine on some host infrastructure that already is in place, or you may even deploy it on dedicated equipment if you feel that it's necessary to do so. But the main reason it's optional, Sarah, is because it's licensed separately. Otherwise, we would just ship it on the image, ready to go.
Right.
Okay. Well, that's all I had for our overview, Sarah.
Well, that's great. It served as a tremendous refresher course for me. We haven't talked about this topic in a while. So we would love to invite all of you to our upcoming events. Tomorrow morning, we are going to have a virtual NAB tour with 1303 Systems, Western Digital, and Caringo. So for any of you who, like me, missed your chance to go to Las Vegas this year for the NAB show, we've got a little teaser of what we would have been showing you at that booth. On May 7th, we have our next Brews and Bites webcast. So that is remote workflows, big files, and big storage, a big problem. And we'll have Robert Brown with Signiant with us for that informal chat about storage. And then, John, why don't you tell us what you have in store for us on May 26th for our Tech Tuesday titled How Object Storage Makes It Easier to Access Your Data from Anywhere.
Sure. A timely topic, to be sure, in this day and age of most people doing work from home. So what we'll be going over, Sarah, is I'll be in the host chair as opposed to the subject matter chair for this one. And we're inviting Ryan Meek, who's our principal solutions architect, to join me. And we're going to discuss how object storage can be used to support your remote teams in today's work from home world.
Great. Well, we've got a few minutes left for questions, and we just had one come in. John, how do you configure backup from KVM?
It's not so much backup as it is basically reinitializing the image, because you're going to have the initial image for Gateway, for Elasticsearch, and so on. One of the things that might be missing here, and it's a key takeaway as to how our specific solution works. Let's say you're concerned about backing up Elasticsearch, for example. You don't want to lose your data in your Elasticsearch farm that's associated with this. It so happens that we have a method that allows you to back up Elasticsearch data into an S3 connector. So what you can do is you can set it up in such a way that the Elasticsearch data is backed up into Swarm Storage proper. It kind of completes the circle of life, as it were, and then you'd be able to restore in that fashion. But another key takeaway that I hope everybody understands about our solution is that the Elasticsearch piece is only a metadata cache. It's not where the actual metadata lives. The metadata lives in storage along with the data. It's all encapsulated and protected in the same fashion. If you were to, say, lose your Elasticsearch farm, you could build out Elasticsearch from scratch with no data, restart the search feed configuration in Swarm Storage, and it will repopulate all the metadata information associated with all the objects in the cluster, and you would go right back to being able to do list and query against the metadata again. So your metadata is fully protected, even in a catastrophic scenario like that. The gateways, they're reverse proxies. They're stateless. They don't really contain any data. If you were to lose a gateway, you would just shut it down, build another one, configure it, point it to storage in Elasticsearch, and keep on going. There's nothing to worry about there in it being persisted. And then last but not least, for the object storage itself, if you're really worried about backup in that regard, we have a couple of ways to tackle that. We have a feature where you can back up Swarm Storage into Amazon S3. I'm not going to go into that in great detail, and in fact, that may be an excellent topic for another webinar, Sarah. But we do offer that feature. And of course, Swarm itself has site-to-site replication support for replicating data from one Swarm Storage implementation to another, from one cluster to another. So even if you were to lose, let's say you had two SSAs, one at site A and one at site B, and they're set up to cross-replicate, and let's say site A gets hit by a meteor, God forbid. You just deploy another SSA at site A, set everything up, it'll be raw, set up the replication feed to site B, and then site B repopulates all the data into site A automatically. So there are a lot of ways to tackle what amounts to backup. Really, it's not so much a matter of backing up individual operating systems and images as it is making sure that your data is fully protected.
And for all of these topics, we have extensive resources on Caringo.com. You can watch webinars on it. We've got white papers. And, of course, we've got experts on hand to talk to you. So you can always just shoot us an email at info@Caringo.com, and we're happy to set you up for a talk with somebody, I would say just as smart as John Bell, but that's a high bar. But we'll set you up with a talk with somebody who's almost on par with John Bell. Or if it's a really tough question, we'll get John Bell himself to answer it for you.
Thank you, Sarah.
Yes, well, we are fortunate that we have so many experienced engineers. I mean, having been in the business for 15 years, we've got a really great pool of talent at Caringo, and we have experts on just about every topic related to object storage. I would say every topic. So, John, it's great to have you back on the webcast, and I'm really excited about our new line of appliances. But, I love shiny hardware, so.
We put a lot of work into that, and we're looking forward to selling a great many of them.
Well, yes, absolutely. I think that, at this time when so many people are working remotely, our ease of management is a real boon to their business to be able to manage from a distance.
That's right. Many of our customers are living that life as we speak, and they're very happy with it.
That's great. So thank you, John, for coming back and being our talent today and letting me sit in your host seat. But first, you stepped on my toes, and now you're going to bump me out of my chair, right?
That's right.
That's okay, guys. He's wearing bunny slippers, so it's okay that he stepped on my toes. Sorry, you knew I was going to share that when you told me, John.
Yeah, that's what I get. That's what I get for sharing.
Well, thank you, everyone, for joining us today, and we hope to see you on our future virtual events and webcasts.
Thanks, everyone.
Have a terrific day.